So students, according to Arrhenius, yes, what is an acid? An acid is a substance which on dissolving in water gives rise to H plus ions as the only cation. I told you HCl will dissociate and give what? H plus Cl minus. Yes. Similarly, take example of sulfuric acid, H2SO4. And it will dissociate and give what? H plus and HSO4 minus. Now these acids are of two types. Okay. What are they? Strong and weak acid. Okay. Now what are strong acid? Strong acid, what happens on dissolving in water? It will dissociate completely. Yes, note down students. The strong acid will dissociate completely. Yes, on dissolving in water. And what we are getting? Aqueous solution containing mainly H plus ions and concerned acidic radical. For example, hydrochloric acid, HBr, HNO3, that is nitric acid, hydrogen bromide, sulfuric acid, H2SO4, all these. So all these are concentrated acids, that means strong acids. So what you will be writing there? Concentrated acid. That means very strong acids. So how we can define a strong acid? Strong acid are those acids which on dissolving in water dissociates almost completely. And the resulting aqueous solution contains mainly H plus ions and concerned acidic radical. Yes, students, all of you understood what is a strong acid? Yes. Now, next is weak acid. What is a weak acid? Now, on dissolving in water, a weak acid does not dissociate completely. See the difference here, students. Strong acid was dissociating completely in water, right? What about weak acid? Weak acid does not dissociate completely. And the resulting aqueous solution contains H plus ions and concerned acidic radical in small proportion. Yes, along with large proportion of undissociated molecules of the acid. For example, you can take example of H2CO3. Yes, carbonic acid, as well as acetic acid, that is CH3COOH, which is your vinegar. Yes, you are using vinegar in cooking, right? So that is a weak acid, CH3COOH, also called as acetic acid. So this way we are having strong acid and weak acid. So I hope you understood the difference between strong and weak acid, students. Yes. Now what Arrhenius said, what is a base? A base is a substance which on dissolving in water gives rise to OH minus ion as the only anion. Like we are having sodium hydroxide, calcium hydroxide. Now bases are again of two types. Weak base, okay, weak base, strong base and alkali. Okay. Now what is strong base? Strong base, what happens on dissolving water? Dissociates almost completely and resulting aqueous solution contains mainly OH minus ion. Yes, what it contains? OH minus ions and concerned basic radicals. For example, sodium hydroxide, potassium hydroxide, calcium hydroxide, sodium oxide. These all are strong bases. Okay, strong base, what happens? It will dissociate completely in aqueous solution, in water, and the resulting aqueous solution, what it contains? OH minus ions. Okay, similarly, weak base. What is weak base? Weak base on dissolving in water does not dissociate completely, and the resulting aqueous solution contains small proportion of OH minus ions, and the concerned basic radical along with a large proportion of undissociated molecules of the base. For example, ammonium hydroxide, NH4OH. Okay, what is NH4OH? NH4OH is a weak base. Yes, so NH4OH dissociates very slowly in water. It does not dissolve completely in water. Understood? So aqueous solution. What is the meaning of aqueous solution? I explained you this. How many of you remember? What is the meaning of aqueous solution? Let me see how many of you remembers. Write the answers in the chat box. Yes, AQ is a symbol. Correct, Purva. What is the meaning of aqueous solution? Yes, dissolving in some solution like water, etc. When you're dissolving in water, it becomes aqueous. Yes, then that solution is called as aqueous solution. Okay, so I hope everyone understood. Now, what is alkali? Alkali is nothing but the bases which are highly soluble in water. Okay, for example, sodium hydroxide, potassium hydroxide, ammonia, all these are alkalis. So we can also classify them as strong alkalis and weak alkalis. Now, sodium hydroxide and potassium hydroxide, they are strong alkalis, whereas ammonia is a weak alkali. Okay, so in this way, how we can classify the acids and bases? Into mainly 5 types, that is strong acid, weak acid, strong base, weak base, and alkali. I hope all of you understood this very well. Classification of acids and bases. Yes? If yes, give me a thumbs up. Give a thumbs up in the chat box. Okay. Only one student has given thumbs up. Where are other thumbs up? Don't know how to do. Okay, reply in the chat box. If you don't know, no problem. Reply in the chat box. Okay, in the chat box, I got the reply. Okay, Latika, Aditi. Okay, Siddhant Kamble, you want to know what is weak acid. Okay, weak acid is an acid which does not dissociate completely. Okay, it will not dissociate completely. Like, for example, acetic acid. Acetic acid is a weak acid. So it will not dissociate completely in water. I hope Siddhant Kamble, you understood very well. Okay, what is a weak acid? Okay, fine. Okay, now moving to the next slide. We are going to learn about basicity and acidity. Yes, what is basicity and acidity? Now, basicity of acids. What is basicity of acid? The number of H plus ions. Okay, number of H plus ions obtainable by the dissociation of one molecule of an acid is called as basicity. Okay, how many molecules of H plus ions are obtained? That is called as basicity of the acid. For example, if I'll tell you HCl. Okay, HCl, if it dissociates, how many molecules of H plus ions we are going to get, students? Reply in the chat box. In HCl, how many molecules of H plus ions we are going to get? Only one. Very good. Only one. HCl will dissociate how? H plus and Cl minus. So how many H is there? Only one. Okay. What about HNO3? HNO3, how many H plus ions are there in HNO3? Yes, only one. Very good, Soumya. Rajesh, it's not 3, it's 1. Okay, HNO3. I'm asking H plus ions. How many H plus ions are there? Only 1. Okay. What about H2SO4? How many H plus ions are there in H2SO4? Very good, Ashwin. 2. Yes, very good, Mitali. 2. Correct. So, next one. H2CO3. How many H ions are there? 2. Very good, Sai. You are right. 2 ions. What about H3BO3? How many H plus is there? Very good, Purva. 3. Correct. Ganesh Shukla, right? 3. Okay. So now you understood what I said. Yes. What is the meaning of basicity? The number of H plus ions. Okay. How many numbers of H plus ions are obtained by the dissociation of one molecule of an acid? Okay. Now next is H3PO4. H3PO4. 3. Very good, Mitali. 3. Now what about CH3COOH, students? Yes, Purva, it is only 1, not 3. Okay, because CH3 is methane. Okay, acid is only COOH. We have to consider how much? Only 1 H plus ion. Okay, in acetic acid, only 1 H plus ion. So that is called as basicity of acids. I hope all of you learned it. What is basicity? How you can define it? The number of H plus ions obtainable by the dissociation of one molecule of an acid is called its basicity. Okay, very good, Soumya. Okay, next is acidity of bases. Acidity of bases. How we will understand that? By counting the number of OH minus ions. Okay, we will come to know what is the acidity of bases. Now I'm going to ask you, in NaOH, tell me students, how many OH minus ions is present in NaOH? Very good, Ganesh, you are right, only one, correct. What about KOH, potassium hydroxide? Yes, Shriram, correct, only one. What about CaOH twice, calcium hydroxide? Yes, Sai and Aditi, correct. 2. Very good, Ashwin. 2. Okay. Barium hydroxide, BaOH twice. Yes, very good, Gayatri. Correct answer. 2. In BaOH twice also 2 OH minus ions are there. Okay. Aluminium hydroxide, AlOH thrice. Very good, Jyoti. 3 are there. 3. Count the number of OH minus ions. Yes, very good. OH minus is 3. What about ferric hydroxide, FeOH thrice? Ferric hydroxide. Yes, very good. Purva, Ashwin, 3. Okay, correct. What about NH4OH? How many OH minus is there in NH4OH? Very good, Ganesh. Only 1. Correct. So now you understood how to find the acidity of base. Yes? How to find out acidity of base? By counting the numbers of OH minus ions. So how you can define it, acidity? The numbers of OH minus ions obtainable by the dissociation of one molecule of base is called its acidity. Okay, so it's very easy, no students? So to find the basicity of acid and acidity of bases. Okay, fine, Shamli. Okay. Okay, we have solved just now. Okay, complete the following table. Okay, so in your notebook, I will give you 1 second just to do it again, which I discussed with you just now. All of you in your book, you can write and keep it with pencil. Okay, how many HCl, H plus ions are present and how many OH minus ions are present. Okay, I will give you time. Those who are not done, do it. Okay, Aditi completed. Very good. Good, students. So most of you have completed this table. Now next we are moving to the concentration of acid and base. How to find the concentration of acid and base. Now here there is a short activity. Solution of lemon juice you have to make. Yes. How to make? You have to cut a lemon into 2 equal parts. Take the juice of each part in 2 separate beakers. You can see the beaker in the screen. Yes. Pour 10 ml of drinking water in 1 beaker and 20 ml in the second. Okay. So in the first beaker, how many ml, students? How many ml you are going to use it? This is the first beaker. Okay. A. Yes, very good, Soumya. We are going to add 10 ml of drinking water in first beaker. What about the second beaker? How many ml of water you are going to add in the second beaker? Very good, 20 ml. Very good, Shriram. So stir the solution in both the beakers and taste them. Is there any difference of the solution in the 2 beakers? And what is that difference? So you all have to stir it and taste it. Can you guess what is the difference now? What will be the taste? Is it sweet or sour taste, student? Yes, sour taste. Very good, Jyoti. Which will be sour, more sour than the other? Yes, very good. 10 ml solution. Yes. because you added only 10 ml water in the first beaker. So first beaker will be more sour. Yes or no? Yes. Whereas the second beaker, it will be less sour. Why is it less sour? Because you added how many ml of water in second beaker? You added 20 ml. Yes. So the taste will be less. That is the main difference. So from this activity, what you learned? The sour taste of the solution is what? Why it comes sour taste? Because, yes, because of what? The solute. Now, what is the solute here, students? Can you guess what is the solute? What you added in water? Lemon. Very good, Sai Fatah. You are sending the image of lemon. Very good. Okay. So we added lemon. So lemon is a solute. And what about water? Water is a solvent. What we call the water? Very good, Soumya. Water is a solvent. Lemon juice is a solute. And when you are mixing both of them together, what we are getting? Solute plus solvent gives what? What we are getting? Solution. Very good, Ashwin, Shabrish. Yes, we are getting solution. Which solution? What is the name of the solution? What is the name of this solution? Lime juice. We are getting the lime juice. Yes or no? Okay. So the quantity of the lime juice or the lemon juice is the same in both the solutions, yet the taste is different. Yes or no? The first solution in the first beaker is more sour than the second beaker. Yes. So you understood what is the reason also you understood because you added 10 ml of water. That's why the sour taste is more in the first beaker. Whereas in the second beaker, we added more water. That is 20 ml of water. So the taste is less there. Sour taste will decrease. That means what? Although you added equal quantity of solute, lemon was equal. Yes, lemon we added half in both the beakers. But what was the difference? Solvent is different. So solvent you added in one beaker 10 ml, in the other beaker 20 ml. Yes or no? So ratio of the quantity of the solute to the quantity of the resulting solution is different. So this ratio is larger for the solution in the first beaker, and therefore that solution tastes more sour. Yes. Whereas on the other hand, the proportion of the lemon juice in the total solution in the second beaker is smaller and taste is less sour. So the taste of foodstuff depends upon what? The nature of the taste giving ingredient and its proportion in the foodstuff. Suppose you're adding sugar. Okay, sugar instead of lemon juice, we are making sugar syrup. In one beaker, you are adding 5 spoons of sugar. In the other beaker, you are adding 10 spoons of sugar. Okay. So what will be the concentration, students? In which beaker? 10 spoon or 5 spoon? Yes, in 10 spoon. Very good, Chetna. That means what? When you are adding the solute, okay, the nature of the taste giving ingredient, that is sugar is a taste giving ingredient. Yes, it depends. So the taste of the food depends on what? The nature of the taste giving ingredient. Similarly, all the properties of solution will depend on what? Nature of the solute and the solvent and how and the proportion. Yes, and the proportion. Suppose if you're making the tea, okay, if you're adding more tea powder, what will happen? The tea will become very strong tea. If you're adding more milk, it will become a light tea. Yes, no? So the proportion is important. If everything is in proper proportion, you will get the good tea, tasty tea. Yes. So similarly, if you are drinking Bonvita, yes, Bonvita milk if you're drinking or Horlicks, whatever you're drinking. If you're adding more and more Bonvita or Horlicks in that milk, what will happen? The taste will go on increasing. It will be bitter. Sometimes it will become bitter also. Yes. If you're adding in proper proportion, how will be the milk? Milk will be very tasty. If proper quantity of milk, sugar and Horlicks or Bonvita. Yes or no? Perfect taste you will get. Very good, Ria. Okay. So now you understood what I mean to say. That means proportion of solute in a solution is called as what? Concentration of the solute in the solution. That is called as a concentration of solute in the solution. Suppose if the concentration of solute in the solution is very high, what we call that solution as? Can you guess what we call that solution? If very high, it is called strong solution. Very good, Mitali. Or you can also call it as concentrated solution. Okay. And while if the solution is less concentrated, we can call it as dilute solution. If the concentration is very low, what we call it as dilute solution. So remember these two words, concentrated and dilute. Okay. Now several units we can use to express the concentration. Okay. What are the units to measure it? The first unit is the mass of the solute in grams dissolved in 1 liter of solution. So what we can say? What is the unit? Grams per liter. Okay. Grams per liter is a unit for measuring the concentration of a solution. Now, second unit is what? Number of moles of the solute dissolved in 1 liter of solution. So what we call it as molarity. And how to write it in symbolic form? Capital letter M. Very good, Sai. Okay. So what we will be writing? M. Capital M. Molarity of a solute is indicated by writing its molecular formula inside a square bracket. For example, if you want to write the molarity of salt, so inside the bracket, you will write NaCl is equal to 1. Okay. Inside the bracket, what you will be writing? NaCl, that is molarity of salt, sodium chloride equal to 1. Means the molarity of the solution of common salt is 1 moles or 1 molar. 1 M means what? 1 molar. Yes, students, all of you understood what are the units? Okay, come on, write in the chat box which 2 units I just told to you, discussed with you. Which are the 2 units we should write for measuring the concentration? Molar, very good, Avdut. Grams per liter, very good. Okay, very good. So grams per liter and molar. Okay, fine. Glory, it's not grams, it's grams per liter. Very good, Divya. Okay. Okay, moving to the next slide. pH of the solution. Now, what is meant by pH of the solution? Yes, in acids, bases, they will dissociate in water. Yes, when we will dissolve in water, what happens? We are getting H plus ions and OH minus ions. Yes, so H plus and OH minus ions are found in different proportions in different solutions. And that will determine what? Property of those solutions. For example, proportion of H plus and OH minus ions divide soil into acidic soil, basic soil, and neutral soil. Yes, types of soil. You studied in geography. Which are the different types of soil? In lower class, you remember? Different colors of soil, red soil, black soil. Yes, white soil is there. Some are acidic, some are neutral, some soil is basic. Remember in geography in lower class, you studied all these types of soil. Yes. So what we learned from this, how you can understand whether the soil is acidic or basic or neutral. Yes. From the proportion of H plus and OH minus ions. That only we are learning in science. Okay. How much proportion of hydrogen ions is present? How much proportion of hydroxyl ions is present? Even in blood also we are writing a positive, yes, negative group, etc. So H plus and OH minus ions should be in proper proportion, definite proportion for proper functioning of the overall functioning of the blood. Yes. So fermentation carried out with the help of microorganisms, other biochemical process, and many other chemical process. They all require what? Proportion of H plus and OH minus ions. That should be maintained within the limit. It should not increase or decrease. It should be properly balanced. For example, let us take example of pure water. Pure water undergoes dissociation, and what we are getting? H plus and OH minus ions. In equal proportion, we are getting H plus and OH minus ions. So because of this property, what we can say, they access both OH and H plus ions. Yes, but the concentrations may be different. What will be the concentration? Can be different. Concentration of H plus ions formed by dissociation of water is 1 into 10 raised to minus 7 moles per liter. At 25 degrees Celsius, how much we are getting? 1 into 10 raised to minus 7 moles per liter. And at the same temperature, concentration of H plus ions in 1 mole solution of HCl is different. That is 1 into 10 raised to 0 moles per liter. So understood what the difference? Yes, here the concentration of H plus ions is different in water, whereas in acid, it is, in HCl, it is different. Yes, so in this way, it depends upon the concentration. Now here in the table, you can see different types of solutions and their pH value. Yes, so percentage of hydrogen ions, that is pH. Now look at the table. So you can see here strong acid and weak acids, strong bases and weak bases. Yes, all can see it in the screen. Yes. Okay, first one is HCl, 1 mole HCl, 1 molar HCl, that is hydrochloric acid. What is the pH given there? 0.0. Yes, because it is a strong acid. Okay. Next is gastric juice. It is having 1, pH is 1. Lemon juice, 2.5. Vinegar, that is acetic acid, 3. Tomato juice, 4.1. Okay. Black coffee, 5. Acid rain, 5.6. Yes or no? So here strong acids, the pH values are given. Now let us take weak acids. Urine, 6. Rain and milk are neutral. So 6.5. Pure water, sugar solution, 7. Blood is a weak base, 7.4. Solution of baking soda, 8.5. Toothpaste, again a weak base, so 9.5. Milk of magnesia, 10.5. Lime water, 11. Then the strongest base, that is sodium hydroxide, 1 mole NaOH, that is having 14. See how the pH value kept on increasing from strong acid to strong base. Yes or no, students? It started from 0 and the strongest base, that is sodium hydroxide, they have given how much? 14. Okay. So the solutions are given and their concentrations are also given. How much concentration of H plus and OH minus ions are present in the solution. That is nothing but pH. What we write in short? pH of some common aqueous solutions. Okay. So similarly, we are having pH of different solutions. Sodium hydroxide, I put blue. Okay. So in this way, common aqueous solutions, the range of H plus concentration ions also ranges from 10 raised to 0 to 10 raised to minus 40. So in the year 1909, there was a scientist named Sorensen. He was a Danish scientist. Introduced what? New scale of expressing H plus ions. How to express this concentration in a tabular form. Who found out that? Danish scientist. What is the name of the scientist, students? Type in the chat box. Yes, Danish scientist. Very good, Nihal. But what is the name I told you just now? Danish is the name of the country. Okay. What is the name of the scientist? Sorensen. Very good, Purva. Sorensen. What is the name of the scientist? Sorensen. He introduced a new scale of expressing hydrogen ion concentration. Okay, which is useful for both chemical and biochemical processes. What we call that scale as pH scale. pH means what? Power of hydrogen. What is the name of this scale, students? pH scale. Okay, what we call it as power of hydrogen. The pH scale extends from 0 to 14. Okay, starts from 0 and ends at 14. Okay, so according to the scale, pure water is having pH how much? 7 means pure water has how much H plus concentration? 1 into 10 raised to minus 7 moles per liter. Okay. pH 7 indicates what? It is a neutral solution. Pure water is a neutral solution. So this is what midpoint of the scale. Total there are 14, no? 0 to 14. What is the midpoint? 7 is the midpoint. Yes? 7 plus 7 is 14, no? 7 is the midpoint. And what is the pH of water? Pure water, it is 7. So what it indicates? It is neutral. Okay, students, remember all these things. So pH is the midpoint of the scale, and pH of acidic solution is less than 7, and that of basic solution is greater than 7. Now in the table you can see all the acids are having less than 7 values. Yes, and all the bases, the pH value is more than 7. Yes or no, students? Yes, from the table it is clear. Okay, so this table gives what? pH values of most of the common solutions. Okay, so this much is very clear to you now, correct? Okay, now what I'm showing you, students, here, what is all these colorful things? What we call them as? This is nothing but how to measure the pH using universal indicator and pH meter. Yes, so these all things are indicators. Yes, universal indicators and pH meter. Okay, so you all know some natural and synthetic dyes are there which show different colors in acid. Some are showing in basic solution. Such dyes that is used as acid base indicator. What we use, call it them as acid base indicator. Okay, in the pH scale, the pH of the solution varies from 0 to 14. Just now I told you, from 0 it starts and ends at 14. In accordance with the strength of acid or base. How much strong your acid is, how much weak your acid is, how much strong your base is. Okay, so depending on that, the value also changes from 0 to 14. So how to show the variation in pH scale? What we need? We need a universal indicator. And what universal indicator will do? It will show different colors at different values of pH. Okay, which all colors you can see in the screen, students? Can you identify the colors and write in the chat box how many colors? Yes, very good, Ria. Red color you can see, shades of red color, shades of green color, yellow color. Very good, Rajesh. What else? What are the different colors you can see? Yes, Avdut has written rainbow colors. Okay, fine. Blue color. Specify it. Which colors? Okay, purple color. Okay, fine. So I am getting different colors over here, right? No, you all can see it. Yes, different colors at different pH values. Yellow, red, orange, green, blue, violet, purple. Yes, so different shades. So a universal indicator is made how? By mixing several synthetic indicators in specific proportion. So synthetic indicators, they are mixing together in proper proportion. Yes, just like how we made the lemon juice. It will become tasty if you are adding in proper proportion the lemon and water. Okay, and salt, whatever you want to add, or sugar. So it will become more tasty. Yes or no? In proper proportion, if you're adding anything, it can be used properly. So universal indicator, how we can make it? By mixing several synthetic indicators. How we should mix in specific proportion. Okay, so the pH of the solution can be determined by means of a universal indicator solution or the pH paper made from it. Okay, now from this we can also make pH paper. Yes, so students, you can see over here the pH paper, everyone. Yes, which is a pH paper, this one. Okay, so pH papers are also available which can be used. Okay, so if universal indicator is not there, you can also use pH papers. So however, most accurate method of measuring the pH of the solution is to use an electrical instrument. Always electrical instrument will give you accurate value. So what is that called as, students? Which is electrical meter shown over here, students? Yes, this one. Okay, this is a electrical meter. Yes. So this is called as pH meter. What we call it as pH meter. It works on electricity. Yes. So that's why it is an electrical meter. Electrical instrument. Okay. So in this method, pH is measured by dipping electrodes in the solution. You can see here one solution. Yes. So what is that solution? This solution. Yes. Over here. That is nothing but, if you want to measure the pH, you have to dip the electrodes. You can see the electrodes. Yes. Electrodes are kept here. Yes. It is dipped inside the beaker. So this is nothing but your pH meter, and it is an electrical instrument. Okay, it is an electrical instrument. So I hope you all understood what is a universal indicator, what is pH meter, okay, how to calculate the concentration of a solution, etc. Yes. Okay. Okay, students. So now let me ask you a few questions. Okay, who will define strong, how to classify acids and bases and define strong acid and weak acid? Raise your hands. How you will define a strong acid and weak acid? Okay. Only 2 students can answer? Yes, 3. What about other students? Yes, now 5 students raise the hand. Okay. Okay, I'm going to